Welcome back to Vision Academy. This is a fifth video in the series of lecturing on Simplex method. In this video, I'm gonna address a special case of Simplex method, that is degeneracy. So we face several types of issues in Simplex method, such as unbounded solution, multiple optimum solution, and degeneracy cases. So this video will help you to understand and help you to solve degeneracy type of problem. Then let us understand what is degeneracy first. So degeneracy, basically it is the process of obtaining degenerate basic feasible solution in an linear programming problem, which means you may face any two types of situation in the problem. What are the two types of situation? Is you may face the values of basic variables are 0. So while we forming the initial simplex table, if the values of some basic variables are 0, then it is the case of degeneracy type of problem. We do not worry about iteration that are followed by after initial basic feasible solution, but in the initial basic feasible solution, if you find any one of the value are 0, which means in this problem x value is 0 and y value is 2, and at this stage we are arrived at optimality condition. So here x value becomes 0. See, even though x value becomes 0, we are going to arrive at optimality condition. This is a one type of problem in case of degeneracy, and we do have one more type of problem in case of degeneracy. Another case of degeneracy is, so there is a tie-up in the replacement ratio. So here the replacement ratio is tie-up. Example, if we have two constraints, in the two constraints we have only same value, so that is 2 2, maybe 2, maybe 2 in even both constraint. So in this case we are in confusion to select outgoing variable. So in this case we are not going to select arbitrarily, so we have some treatment. So let us understand what are the treatment, what are the steps to break this degeneracy type of problem. Firstly, what we want to do is we have to compute the non-negative ratio of first column of identity matrix. For this we have to select first column of identity matrix, and here we are not going to consider quantity column. So to find out the replacement ratio, we were dividing entering variable by respected quantity column, but here we won't consider quantity column. Instead of that, we will consider first column of identity matrix. This, using this we will divide entering variable. Say for example, the identity first column of identity matrix is 0 and entering variable is 4 and 2. So in this case we will find replacement ratio by 1 by 4 and 0 by 2. So this is the case how we deal degeneracy type of problem. So after doing so, choose the minimum of the value occurring at a place of tie. So this is we know how to select minimum value in the replacement ratio. So again, after doing so, if there is a tie again, so we have to compute the ratio using second column of identity matrix. Firstly, we considered first column of identity matrix, so there also we faced tie. Then here we want to consider second column of identity matrix, and we will continue this procedure until we obtain the result or till the ratio do not break the tie. So this is how to break the degeneracy type of problem. Now let us consider a problem for calculation of degeneracy. So here we have a problem. This is a problem. In this we have two constraints. So that is maximize z is equal to 3x plus 9y. So we have two constraints. One is 4x x plus 4y, x plus 2y lesser than or equal to 4. And since we have two variables, we have x and y are greater than or equal to 0. So here we have to rewrite this general LPP into standard form of LPP. So here we have to give two treatment. The objective function is already in the maximization form, and in the subjective constraint here we have to make it equality, that is in the both constraint. Here we will remove inequality. Instead of that, we will add a slack variable because it is a lesser than or equal to type. We will add a slack variable and remove this inequality, and we will consider it here in the objective function and in the non-negative also. So in here you can see the final result of standard form of LPP. I have rewritten in the standard form of LPP. So here 3x plus 9y. So we have added a slack variable here, and we have considered the slack variable into the objective function, and a slack variable has no value, so I have considered 0s1. And here also I have added a slack variable, and I have considered here, and I have also removed inequality in both constraint, and I have also considered s1 and s2 in the non-negative. So this is in the form of standard form of LPP. Now let us move to calculate third. Let us replace all the values in the initial simplex table. So on the right side you can see. So I hope you know how to form this table. Here I have formed x, y, s1 and s2, and in this table, in this row, I have inserted cj value, which means the values which are in objective function. So x value in objective function is 3, and y value in the objective function is 9, s1 value in the objective function is 0, and s2 value also in the objective function is 0. So on the here replacement ratio column is this. Here I have directly calculated, since I am presenting in the PPT mode, I have directly calculated, but I will explain you here. So on the left side we have basic variable. In the basic variable we have to consider slack variable as a basic variable. First, in the initial simplex table we have to consider slack variable only, and profit or unit coefficient of basic variable is 0. So here look at here, in the objective function coefficient of basic variable here 0. So we have considered 0, and quantity of first constraint is 8, and quantity of second constraint is 4, and x1 value in the first constraint is 1, x2 y value in the first constraint is 4, s1 value in the first constraint is 1, there exists s1, and in the s2 value there is no s2 value in the second constraint, so I have considered 0, and in the second constraint x1 value is 1, in the second constraint y value is 2, in the second constraint s1 value is 0, but there is no s1 value in the s1 in the second constraint, so I have considered 0. s2 value in the second constraint is 1, there exists s2. So this is how I have replaced all the values into the initial basic feasible solution. After doing so, we will calculate we will see identity matrix. In the initial basic feasible solution there will be definitely identity matrix, that is 1 0 0 1. So after that we shall move further for calculation of zj. So for zj we will calculate 0 into 1 plus 0 into 1. 0 into 1, 0 into 1 is 0. Then 0 into 4, 0 into 2. 0 into 4 and 0 into 2 is 0. So whatever you multiply by 0, it would be 0. So since in any initial simplex table, zj value will be 0. So 0 into 1, 0 into 0 is also 0. 0 into 0, 0 into 1 is also 0. So by doing so, by multiplying and adding each constraint value, we have arrived at zj value. Now we will calculate cj minus zj. So we know that formula cj minus zj. Here this is a cj column and this is a zj column. So we have 3, and here we have 0. 3 minus 0, 3, and 9 minus 0 would be 9 only. So 0 minus 0 would be 0, and 0 minus 0, so this is also 0. So we have arrived at optimality condition. We have to check optimality condition in the Cj minus Zj. So what is condition? All Cj minus Zj value must be greater than or equal to 0. So let us check it. So there is a positive value in the Cj minus Zj, that is 9 and 3. Since there are two positive value, we have to consider highest positive value. So 9 is a highest positive value, and y will be incoming variable in the next iteration. So after finding that incoming variable, we have to find replacement ratio. So replacement ratio can be found by dividing quantity divided by entering variable, that is 8 by 4. 8 by 4 is 2. 4 by 2 is 2. Oh my god. Now I told you what is degeneracy case. In the both constant we have same replacement ratio, which means there is a tie in the replacement ratio. So this is the case of degeneracy type of problem. So I told you how to break this degeneracy type of problem. So let us see some sentence how to break the degeneracy problem. So there is a tie in the minimum replacement ratio as it is 2 in each of the two rows. Now we should not select any row arbitrarily, which means we don't have choice to select any one of the row. So instead of that, we will proceed as follows. We divide non-negative ratio of first column of identity matrix. Here you need to understand very importantly, you have to select first column of identity matrix. In that too, it must be non-negative, which means there must be negative. So in this S1 is a first identity matrix, and this is a S1, this is the values of S1, that is 1 0, and these entries, by this entry this will be divided by entering variable, and the entering variable y is entering variable here, y value 4 2. So we have replacement ratio as 1 by 4, this is 1 by 4, and 0 by 2. So 0 by 2. When we simplify this, we got 1 by 2 and 0. So this is the replacement ratio. This is how to find replacement ratio in case of degeneracy type of problem. So you can see I told you here how to select a degeneracy type of problem. So this is a entering variable, incoming variable, and first identity matrix is this first column of identity matrix. So we have to divide identity matrix value by entering variable 1 by 4. So this 0 by 2. So after considering this procedure, we got a final value here. So look at here. Earlier we got 2 and 2 in both rows. Now we have 1 by 4 and 0 0. So now we shall move further. So that is we can go further for calculating incoming variable. So here 9 is the highest value. So we can we have calculated this incoming variable, and we have found 1 by 4 for replacement ratio, 0 by 2. So we have 1 by 4 and 0 by 4. Now we have to calculate outgoing variable. You know that which value to consider in for the outgoing variable. We have to consider lowest value. So here 0 is the lowest value compared to 1 by 2, and since it is the lowest value, we have to mark it here. That is so this is S1 is a outgoing variable for next iteration, and this is a intersection. This intersection will be the key element. So using this, let us formulate next iteration. So for next iteration, S1 and Y will be basic variable. Firstly, we have to ensure there is a unity in the Y. So it's in the S1 there is already unity. In the Y, let us check whether it is unity. Okay, there is no unity, which means this 4 value must become 1 and this 2 must become 0. So then 1 0, sorry, this 2 must become, this 2 must become 1 and 4 must become 0. So which means we have to, and since it is a key element, we have to divide this whole row by key element. When we divide that key element, we will 2 by 2 we will get 1. 2 by 2 we will get 1, and in this we have to multiply the result of this value by -4. Then sum of the rows will be 0. So this value will be 0. Let us have a look and learn how I have done it here. So look at here, the same table I have pasted it here to make you understand. So to make key element unity, we divide second row by 2. Second row, what is second row? This is second row. Firstly, we have to make unity. Okay, unity in the sense 1 0. There is a unity in the identity matrix. Only two values are allowed, 1 0. So the y value are not in unity, so we have to make it unity. So we have to make it unity. This value must be make unity, so that means 1 and this will be 0. Okay, so for that I will consider second row. So here the complete result I have shown you here. So first row I have considered as it is. To check identity matrix, first row I have considered as it is. The incoming variable I have given treatment. Since instead of s2, incoming variable is y, and that profit unit is 9. This is profit unit is 9, and now every values I have considered by dividing by the key element. So 4 by 2 by 2 is a key element and we have to make it a unity. 4 by 2 is 2, 1 by 2 is 1 by 2, and 2 by 2 is 1, 0 by 2 is 0, 1 by 2 is 1 by 2. So now you can check there is a unity in the y column, y row. So this has become 1. So since the desired form is 1 0 0, sorry, this is the desired form is 0 1 1 0. Okay, look at here in the S1 1 0 is there. In the Y, here there is 1, here 1, and this must become 0. Okay, this must become 0. Then we will have a identity matrix. For that we have to multiply second row, this row, by key element only. Key element is 4 here. By -4 we have to multiply. Then we will get a new row for this row. Instead of S1 we will get a new row. So let us see how I have done. So this is the same table for which I have divided by key element. Now let us make another column. In the key element is 0. Now we have to make another element in the column Y. Here in the column Y, that is 4 0, that is identity matrix. So we multiply second row in the sense this, and we have to make this 0. So why should we give treatment to second row means, however this row will be considered for the y only. For this row, after multiplying this second row by -4, we will take sum of the rows. So by this and multiplied by -4, this we will take a sum of the rows. So that row only we will be considered here. You will see here how I have considered. So second row in the column by the negativity of key element. So 4 is a key element here. So this is a complete result you can see here. So second row, firstly I have considered second row and I have multiplied the second row, each value in the second row by -4, except this except profit and our unit. We should not multiply, we should not make any we should not give any treatment to this profit or unit, because these are the coefficient of basic variable. Okay, this will remain same. Okay, now second row. So second row here, 2 into minus 4, that is minus 8. So 1 by 2 into minus 4 is half of it, minus 2. 1 into minus 4 only. 0 into minus 4, minus as a 0. 1 by 2 into minus 4, that is also minus 2. So after this we have to consider first row. First row here, as it is S1 constraint, first row I have considered as it is. So after this we have to take a sum of the rows, which means a plus or minus. We have to make minus 8 minus 8 plus 8 0, minus 2 1, minus 1 because minus value is highest, minus 4 4 0 0 1 0 plus 1 1, minus 2 0, minus 2 only. So now we have considered we have arrived at a final stage of this, which means we have to consider this sum of the row table to the first row. Here instead of this S1 row, we have to consider this sum of the row, because we have to make this 0. So here there is a 0. Okay, and this row will be carried as it is for the second row. So the same thing I have done in the next table. Look at here. So the same thing I have done. So for this I have considered, so for first row I have considered sum of the row operation that we obtained after multiplying by minus 4, and for second row we have considered that we divided by key element, that row we have considered here. So here you can see 9 2 1 by 2 1 0 1 by 2, and 0 0 minus 1 0 1 2. So this you can see. So here 0 minus 1 0 1 minus 1, this is for first row, and this is 9 2 1 by 2 1 0 1 by 2 is for second row. So we let us check that replacement ratio now here. So basic variables are S1 and Y. So S1 is this, Y is this. So it is perfectly in identity matrix, that is 1 0 0 1. This is perfectly in identity matrix. Now we shall move further for calculating ZJ. So ZJ, you know how to calculate ZJ. 0 minus 1 plus 9 into 1 by 2. Okay, 0 minus 1 is 0. 9 into 1 by 2. 9 into 1 by 2 will be 9 by 2. And 0 into 0 0. 9 into 1 9 only. 9 into 1 9. 0 into 0 0. 9 into 1 9. So 0 into 1 0. 9 into 0, it will be 0. And again 0 into minus 2, that is also 0, and plus 0 into 1 by 2, which will be 9 by 2. So we have calculated ZJ also. After calculating ZJ, we shall move further for calculating Cj minus Zj, and this is a Cj value and this is a Zj value. So let us subtract Cj by Zj. 3 minus 9 by 2. So you have to make a separate calculation for this. That is a 3 by minus 9 by 2 will be minus 3 by 4, 3 by 2, and 9 by 9 minus 9 will be 0. 0 minus 0 will be 0. 0 minus 9 by 2 will be minus 9 by 2. Okay, we have calculated one more thing, that is Cj minus Zj. Now we have to check optimality condition. You know that condition is all Cj minus Zj value must be lesser than or equal to 0, and here minus value, here 0, and here 0, here also minus value. So all values are in lesser than or equal to 0. So we have arrived at optimality condition. So before we declaring we are arrived at optimality condition, let us check what are the basic variable. So basic variable is y and s1. So here when we considered y, we have y value here. Y value is 2, but we don't have x value. So in the case of S1, we have there is no x value. We have not considered that. Since we have not considered that, it will be 0. Okay, so in the basic variable there must not be any slack variable, which means let us initiate another iteration. So here we have already there are no values here, since we have to select most positive value. There is no single positive value, so we have considered this y already, and let us consider x. Simply arbitrarily let us consider x, and we shall see what is the impact of considering x. So let us I am giving you example. Let us consider x as incoming variable for next iteration. Okay, next incoming variable. So now let us calculate quantity, and let us calculate replacement ratio. For calculating replacement ratio, look at here, 0 divided by -1. We should not select, we should not divide minus value, we should not consider negative value for calculation of replacement ratio. So this column cannot be taken for calculation, and let us divide 2 by 1 by 2. We will get a positive value, but there is no use for again calculating this y value, because we have already considered y as a basic variable. So there is no other way to move forward, and this is a final optimality condition. So we have arrived at optimality condition. So I have replaced the x value and y value to the objective function. So we have arrived at optimality condition when x value is 0, y value is 2. So maximize z is equal to 3x plus 9y. This is a objective function. There is no value for x, that is 0, so which is 3 into 0, and we have value for y, that is 2, that is 9 into 2. So 9 into 2 is 18, so that z value is 18. We have arrived at optimality condition, so that is z 18. So thank you so much for watching. Please do subscribe to my Vision Academy YouTube channel.